Good morning. My name's Paul. Welcome to Electrobit's offices here in Berlin, where we're going to be addressing the subject of the software-defined vehicle and the impact of artificial intelligence. And we have two adults in the room. I can introduce my colleague Moritz and Jan Savitsky to come and join us.
Hey, Paul. Thank you for
Good morning, guys. Had a safe trip here into Berlin. You're based here. I appreciate that, yes. Yeah. Let me just go straight to you, Jan. CertifAI is doing what and where you've come from? What's your development?
We are providing external test services of AI-based applications. So we basically look at an AI component and we make an assessment. Is this AI component developed according to state-of-the-art and existing legislations?
Right.
And that helps companies with reducing liability risks, with becoming compliant, and with simply establishing trust with their customers. And yeah, it's a lot of fun.
And Moritz, you've been with Electrobit now for 10 years. You're a software strategist, right?
Yes, so I do have a background in architecture, and I actually like being at the interface between technology and business. Mm-hmm. I think for the software-defined vehicle, you can't separate both. Yeah. It's an organization as well as a technological challenge for a lot of companies. And this is what I'm really passionate about, of driving the industry towards software-defined vehicles and actually making that transition work.
That's a cool point to jump in. Where are we at the moment in terms of the user experience with the software-defined vehicle, and what kind of impact AI is going to have on that user experience? Moritz, if you want to give us a take on that.
So I think there's still quite a bit to go for software-defined vehicle experience. What we do want to get to is that the car gets better over time. Right now, when you buy a new car and you drive it off the lot, it only goes downhill, right? And where we want to go is that it actually improves its user experience. You actually want to get new value to end customers. And I think AI can help us in two parts. One is, can we actually improve the user experience within the vehicle with new software functions? And the other one is, can it help us to develop the software quicker and actually get new functionality for end customers out quicker? So really to improve the time to market for new.
Well, let's kick off that first point, that user experience, Jan. How can we make that happen?
So first, I'd like to paint a picture of AI being a loose screw. What do I mean by that, right? So AI is cool. You can build new tools into your product. You can use it to improve existing products with, putting some screws there. But the AI is going to break at one point in time. And where we have to get to with the SDV is to really tighten the loose screw, okay? With deterministic software, we figured out ways. We'd have unit tests, end-to-end tests, integration tests, validation, verification procedures. With artificial intelligence, which is statistics-based, it's a little bit more difficult. But we can absolutely get there. And if we do it, we can have a big positive impact on the user experience on many levels.
Okay, but it's not just about the user experience, is it? It's actually about getting to SDV as well. How is that going to work?
Well, for the SDV, when I look at interaction, so how do you interact with new software being installed in your car? And autonomous driving is probably still a bit out. So how do you interact with it? How do you convey your intents to the car? How is the context being evaluated? I think AI can assist a lot in these scopes to actually get an intent-driven, context-aware user interface for end customers. We see a lot of aspects in driver assistance where actually AI algorithms outperform traditional approaches. I think there we have a lot of potential to actually improve the interaction and also the efficiency in interaction between the user and the car.
I think that's quite a lot about the theory. I think we need to kind of dive a little bit deeper now into actually how it's going to affect the user experience. I mean, if I come from a journalist background where I'm looking at how ChatGPT has affected my area of work, would that experience be similar in the automobile environment? What do you think, Jan?
So first of all, I'd like to say humans like to use technology that works, okay? One of the core design principles of technology, and basically any product, is don't make me think, okay? Now, with AI, it does make you think quite a lot, right? And this is the issue. So if you just imagine a laptop and you turn it on and it turns on 9 out of 10 times, it's going to frustrate you, right? And with AI, we've become very good at getting to this 90%, but still not good enough that we can just seamlessly trust it and say, okay, it's definitely going to do what it's supposed to do. And this is going to put a mental load on the users of people who use AI, and counteracting this mental load by clearly saying what it can do or what it cannot do, and finding failback path where the AI is basically not working, where we just use a traditional deterministic method to basically answer user requests, I think this combination is going to be very important to develop a stellar user experience.
A stellar user experience we talked about,
Very simple example that's really down to earth. You're commuting back from work home, and you want to pick up vegan Indian food on the way. How do you make that in your current user interface? It's simply impossible. What you would do right now is pull out your smartphone, start Googling.
Not while you're driving.
Not while you're driving, hopefully. And then trying to insert that address in the car. But this is what I mean with intent-driven, context-aware. So the car already knows where you are. The car already has internet access to see where possible restaurants for this would be, even at a distance that you could pick it up right when you get there. So these are the points where really the interaction can improve a whole lot, and where you wouldn't copy the interface from smartphones directly. Because a vehicle is not a smartphone on wheels, it is a mobility device. So
we've talked a lot about how, I mean, it's improving the speed of how things are actually delivered. The user experience is not just about the range of information, it's the time that it takes to give you that information, particularly in an automotive environment where time is of the essence. We haven't talked about safety as well. I mean, the other thing is the impact of actually errors happening within that automotive. This is paramount. I mean, if your computer goes down for 1 minute, that's a problem. It annoys you. But if your car goes down for a millisecond, you're in the Armco.
Yeah, absolutely.
So it's going to annoy you even more, right?
It is going to ruin your day. How can we deal with that situation?
Yeah, so let me first start by maybe explaining or visualizing how currently automotive testing works. Okay, so the big test companies, they basically get a vehicle, and usually they speed up the vehicle. If they want to test a front assist that has some AI in it, they usually have a dummy. The dummy is very often white, has a red shirt, and has blue pants on, right? And then the dummy is basically brought into the street. I'm oversimplifying. And then the car should stop, right? But when you use AI as a front assist, there's lots of uncertainty that's also integrated. The AI component is just a very minor detail, right? It's just there to detect is there pedestrian or not.
Right.
And this impacts the safety of the overall system, because then it has to go into steering, it has to go into braking, and it has to go into all these different path planning modes. And with AI, sometimes the car brakes and sometimes it doesn't brake. You know, back in the days, you had same test parameters, same results. With AI, same test parameters, and just because the sun is just in a weird angle, different results. So that's currently breaking, in my opinion, how the homologation process works, and this is where we have to get to. And I think it's two components. One is the statistical approach, simply saying, hey, we've driven 1 million, 10 million, 100 million miles, we have less errors than a human, we're good. The second one is really dedicated risk analysis and AI component testing. And if we combine these two paths, I think that's a good way to make it as safe as possible.
I think that's the time to go into a deeper dive, guys. Shall we?
Sure.
I need more coffee.
So let's get into this deep dive stuff. I mean, we've basically got 3 areas that we were talking about the infotainment. We're talking about the predictive maintenance issue. And remind me, there was one other thing. ADAS. Yeah. Let's talk about the infotainment, because for the user, that is kind of the be-all and end-all, perhaps. What do you think?
I think I've already talked about context-aware, intent-driven. I think one of the other advantages is that also the infotainment can grow with you as a user over the time of ownership of the car. I mean, when you take the SDV value proposition again, that it gets better over time.
I think a customer would love that idea.
Does the car also get personalized over time as it learns your preferences? But I think really the point that you made before is, does it learn your habits properly? Because 90% is not good enough, right? I wouldn't want to have a car that makes 10% wrong predictions on what your preferences would be. But I think really the point that the car actually learns your preferences makes it more your personal thing, makes you feel at home. So I think this is one of the perspectives where AI in the car, in the cockpit, can actually help you quite a bit to improve the user experience over time.
We talked as well about how that user experience is with different systems, about replicating for example, the phone environment into the car. Currently, it's not where it should be. I mean, I know that you have quite controversial views on this.
Yes, so personally, I'm not a huge fan of trying to replicate a smartphone screen in the cockpit.
Right.
In the end, at least as long as we're not autonomously driving, the context is a different one in which you operate. You still need to keep your eyes on the road. And therefore, the user concept needs to be a different one. It's a mobility device. So a smartphone's interface is built to maximize user attention. They want you to keep your eyes on that screen for as long as possible. In the car, I'd rather have the opposite. So I want to keep my eyes on it as little as possible, as long as I'm driving myself. And then the question is, what does a user interface for this need to look like? And this is, I think, where AI really ties in.
This is the thing, isn't it, with certainly the safety aspect. We're not talking about 98% security. We want 100% where possible. How can we guarantee that?
I mean, that's a beautiful opportunity for AI, right? So get away from the screen, but maybe use voice interactions, right? And in the past, voice interactions have been really, let's say, stubborn or not really working as well as they should be. With AI, we can unlock new potential to give directions to the vehicle and to get the information that we want. And so we could basically have our eyes on the road while we're speaking to the vehicle. But then again, how do you make sure that it's doing what it's supposed to do? And as a premium manufacturer, you would like for the system to basically say, if you ask it what's, the best car brand in the world, to say their name and not somebody else's name. So you have to have some level of customization and testing. But I think in the infotainment area, it's fine. The added value we get with AI outweighs the benefits of it basically giving a wrong answer to a question every now and then, as long as you educate the user about it, right? So, yeah.
Education.
Yeah.
So that's the infotainment side of it, but we also talked about one aspect, and this is the predictive maintenance aspect.
Absolutely.
How does that play into, I mean, as a user experience, I know that I rely heavily on my dealer, and I want to know when.
Sure. Let me just break a bone here for traditional artificial intelligence, right? Gen AI is fun, has all the board attention, but they are traditional machine learning-based algorithms that work very well. Right. And if you actually look what companies are putting into production, it's very often the traditional part and rarely the Gen AI part. We can talk about Gen AI on the process side. That's definitely an opportunity there, but simple like LSTMs or simple decision trees to help you figure out, okay, how is my battery performance degradation, right? Do I have to be worried about the battery performance? Do I have to be worried that it has to be changed? Do I have any warranty issues or not? That can be beautifully done with more explainable and traditional machine learning algorithms. And I would just really like to encourage everyone to not forget about that. It's also fun. You can create a lot of value with it, and that's what it really helps on the predictive maintenance side. Sensor virtualization. Topic as boring. If I would go to a board meeting with, let's say, just pure sensor virtualization, it wouldn't be as funky as if I would come in with a new Gen AI-based chatbot. But if you virtualize sensors in a vehicle, you can save a lot of money for volume manufacturers, right? So replacing sensors through machine learning-based detections, that's also where a lot of value is. So it's kind of the hidden traditional machine learning that we should also look into.
So this is reducing the time to market issue for the product, right?
And you mentioned predictive maintenance, and I think this is where it again ties back to SDV. So with SDV, you're starting to roll out new functions to vehicles that you've already sold. Right. So the big question always remains how to monetize on it. You still need to justify then invest. And when I now look at willingness to pay for users, for customers, for additional software functionality that you put in the car, I think actually the field of commercial vehicle fleets is hugely interesting. I think predictive maintenance is hugely interesting because it helps you reduce downtime of your fleet. So the car can already tell the next dealership what spare parts it will need to get repaired or maintained. so that the car doesn't need to sit there to wait an entire day for a spare part to arrive.
So glad you mentioned commercial vehicles, because that is absolutely a growth market for AI. Yeah.
If I can just give one more example, right? So we spoke to a logistics company, and they were carrying a specific type of goods. And these goods were basically put in check by one device. And this device was very prone to failure, specifically during winter times or even also during summer times, right? So to temperature differences, it was really hard time working with it. For them, they had about like 80% accuracy in their predictions, and that was absolutely good enough, because the only thing that they would tell their customers, like, hey, watch out, we suspect that this device might need to be repaired within the next 2 weeks. So plan ahead, go to garage shop and rather check it out, because the downside of fully losing a load because this component failed was way bigger than simply going to garage shop, get it checked out, and having the assurance that it's going to work the next time. And it's a wonderful case where you don't have to be 100% accurate, but can still provide tremendous value for the customer.
That's enormous value for the customer.
Absolutely.
Yeah, I agree. We haven't touched on it, but we should.
Yeah.
Generative AI.
Yay.
Tell me. I mean, we've obviously seen it in so many other areas, but how is it going to play into the automotive space? Moritz, maybe you want to kick off, and I know you definitely want to talk about this.
So for the immediate user interaction, I think it's going to play a significant role in customization.
Right.
In user interaction, so really to drive the way that the user communicates with the vehicle, and how to understand the context of the vehicle. You mentioned the virtual sensors, for instance. What does it mean if I am in a certain location under certain weather conditions? What does it mean in terms of how I should drive, how I should route my vehicle? Should I avoid certain roads? These kind of things. And I think in understanding the context better, this is where GenAI can help quite a bit. The other part, and I think we'll also talk about that, is the development process.
Right.
How to actually develop the software for automotive, because I think we can speed up the development process tremendously by using GenAI in software development.
There's the man in the room.
So I do have a slightly different take, just being that I think GenAI is very good, right? And I do not want to code and work on software without GenAI copilots anymore. But we have to think about it a little bit differently, because when I talk to people who use GenAI, then often they say, well, we just have to get rid of the hallucinations, right? That's not possible. Let me say you this. It's a core feature. You want the hallucinations in GenAI. It's made to hallucinate. And you're lucky enough that it hallucinates the right things that you want it to think, okay? And you can spend a lot of effort in putting guardrails on it and making it more accurate. But even if you give it access to all of the code that you've ever written in your life, even then there's a chance that it will make some sort of issues later, okay? But that's still wonderful. I think it can absolutely give a productivity boost. I would just not say as much of a productivity boost as many people, let's say, hope or want for, because you have this added mental load that you have to check for every line of code that was written, test that was created, requirement that was written to a certain degree. But it's absolutely valuable, and we should definitely use it. And there we also don't have to be 100% accurate. And I would just encourage everyone, if you think about the GenAI product, think about what's an acceptable rate of failure for it to still be good enough. Is like 9 out of 10 requests good enough? Do I need 95 out of 100 requests to be good enough? And then depending on that level, for it to be good enough, just determine how much effort you basically put into it.
I tend to compare the coding assistants to pair programming with a junior or senior developer, somewhere in between probably.
What does that mean?
So it's a pretty good programmer, not a deep expert in a certain field. And pair programming is a practice where two developers actually sit and program together on a piece of code. And you can replace one with a coding assistant based on AI. So the output that you're going to get out of it is not always going to be correct, just like junior developer might not always be correct, or might not have all the context that you need and all the use cases or the special hooks that you need in your source code. But it really gives you a productivity boost, especially if you're not familiar with all the development processes, a specific programming language, certain protocols that you need to attach to. So it can give you that context that you're yourself not too familiar with.
Right.
You still got to be an experienced developer. I don't think that you're going to write awesome code just by pasting something into a coding assistant. But it really gives you that productivity boost, and you're in the end still responsible for the source code that you provide.
And let me just add one more thing. So everyone's looking for efficiencies right now, right? So Germany doesn't sell as many vehicles as they used to. We need to cut costs, and then there's always the business case is very easy for Gen AI. You can just say, hey, I can automate 10,000 hours away here, and I can automate, I don't know, 12,000 developers hours here, and that translates into X amount of money saved. Calculation is often not that easy. I know you need a business case, but Gartner also found out that if you simply have more time because it's done quicker, that doesn't mean you put more time into writing PowerPoints or writing code, right?
No.
Grab another coffee, which is also nice, right? Which also helps a little bit. But I just want to caution everyone from thinking, hey, we save 10 minutes a day here, so we can write 10 minutes more code. That's not a one-by-one calculation.
Speaking of grabbing another coffee, that seems like a good idea. Okay.
Is Gen AI taking our jobs?
I don't know, but maybe the coffee machine is waiting for us. That'd be really cool. So, thanks, guys, for coming in today. That was a fascinating look at what's going to be happening with the world of artificial intelligence, and also what's happening in the very near future. Have a great day. See you soon.
Thank you for having us.
Cheers.
Thanks,
Bye-bye.